When you start writing JavaScript, one of the first things you learn is how to use the console object called the log method to send content out to the console, right? So when this JavaScript runs, console.log hello world shows up here. What a lot of people don't know, though, is that you've got other functions on the console that you can use. I'd like to take a look at some of the semantic logging functions right now, which are going to help you when you build a much larger application. It can be helpful to have different kinds of log messages. So for instance, you might want to warn a developer who's using your library that something they're doing, maybe this works, but they should be aware of the fact that they could be doing it differently. You'll find this a lot. React is good about this. If you're using one version of the React library and you make some API call that they know they're going to deprecate in a future version, you'll get a warning in your console saying, hey, maybe don't call this function, call this other one, because if you roll up to the next version of React, this won't work. But for now, it works. I'm just warning you, right? So you got the nice yellow exclamation point there. Up here, you can see that there is one warning in the console. It's just a way to like annotate your console output with a bit of additional information for a developer who's looking at the console. If something goes a little bit more seriously wrong, you can also say console.error. And when you use console.error, things escalate. We get a little red X up here. We get the red X here. This is bright red, and it includes a built-in stack trace. So you can step through, figure out where things went wrong. This is useful. This is something you might want to put in, when a remote endpoint broke and the kiosk hasn't initialized, right? Throw yourself an error so that you can step in, see exactly where things went wrong, step through the stack and start debugging, right? Don't just do a console.log, do a console.error. You can also say console.info. This is useful if you just want to call something out, right? It's just like, hey, you've got a little blue circle with an I in it. This is to let somebody know that something happened. And it's a little bit more, it catches the eye a little bit more than just a console.log. So maybe if you've got an app that's going to be running for a long time, and I don't know, like once a minute, it refreshes its own internal state by calling some external API, then maybe once a minute you can put down a console.info just to let a developer who's debugging this see at a glance that the correct info has come out as expected. And then finally, you can say console.debug. And it works just like console.log, except it's blue. That's the only difference. But it can be helpful, if you're maintaining a large application and log and warn and error and info are all being used all over the place. And let's say you're on a feature branch somewhere just doing a quick bug fix. Well, if you say console.debug for the fix that you're doing, you can stick those debug statements in everywhere. You get your debug content out in blue, and then when you're done, you can git grep and delete all the different instances of console debug without worrying that you're actually accidentally going to delete some logging that somebody else was relying on. So those are the 5 core semantic logging methods on the console object. And one of the advantages of using them is that when you go to look at the log from an application that's been running, you can filter. You can filter to only show errors. You can filter to only show warnings, to only show info, only show log, and only show debug. And you can then further refine those filters with regular expressions, and there's a couple other tools here that are pretty handy. But next time you go to reach for a console.log, ask yourself, am I really just trying to log something out, or is there something that my logging method can communicate to a developer who might be debugging this later? Should I maybe be using a console.warn here instead of a console.log, or a console.info? Is that going to help? These are just additional tools in your toolbox to help you better communicate with your fellow developers, including your future self, as you go through and debug something you've written. So if we say console.log hello world, we see that string pop out. What a lot of people don't know, though, is that if you pass these in as multiple arguments instead of as a single string, you're going to get the same output. Why? because it doesn't matter. Any arguments you want to pass in here, it takes an infinite list, and all it's going to do is put a space between each of the arguments and spit it all out as one long string. So that can be pretty useful. Additionally, as you can see, you don't have to use strings as arguments. These can be any object, including something like an actual object. You know, something like this, which doesn't have a toString function or anything like that. This is JavaScript. We don't need no toString function. It knows how to render everything as like this JSON-like thing, and your Chrome debugger is going to allow the console to represent this with these little arrows so you can expand and collapse. And so anything that you can reference in JavaScript, you can log out to your console, and it's going to do its best to render it for you in a helpful way. One thing that you might not know, though, is that there is a special case in console.log where if your first argument is a string, you can actually use string substitution the way you might do in like C, right? And that works by, let's say, hello world, my name is, and I say %s, that tells it whatever the next argument is, interpolate it here as though it were a string. So when I run this, I get hello world, my name is Mick. If I add more of these substitutions, then I can just keep adding arguments to the end. So here I said %s because I want it to represent it as a string. Here I said %d because I want to represent that as a digit. And I'm 33. So you can see here that correctly interpolated those values. This only works when the first argument is a string, and then it's going to step through each of these in order and coerce whatever arguments you provided here into the data type you've specified. This includes, by the way, objects. If you say %o and pass an object in, that's going to work as well. Now, one really cool type of substitution, this is really technically a special case of substitution, but you can say console.log, and you can say this is my %c output, and that C actually turns it into CSS. So I can now here specify color, let's say blue, font size 33 pixels. And when I run this, and so this is a pretty cool feature. I have not like played with this to see if you can do background images and stuff like that, but if you ever want to really surprise somebody who's reading your code or the console logs from your library, you could always do some style string substitution in your console logs. Do you ever find yourself in one of those situations where you've got like a whole bunch of data processing going on, for instance, and you're trying to log stuff out, and you want to make sure that visually you can tell how things are grouped together in your logs? So this is going to be a contrived example, but let's just say like for I equals 0, I is less than 100, I plus plus. So this loop's going to iterate 100 times. We're going to say var num equals math.random times 100. So pick a random number between 0 and 100 times. And we're going to say console.log, picking a random number, console.log, number greater than 10, num greater than 10, console.log, number greater than 50, right? And so we're logging out like these kind of related statements here, and like that works. It's all still in order, but like visually it's not great. So like maybe I'm just going to keep giving you bad examples here so you can see what we're fixing. Maybe you figure out that if you pass in the escaped T character, that's going to insert a tab. And then you're like, oh, awesome, cool. Now stuff's visually grouped. that's still like not the right way to do this. There's a console output method called group. And it works like this. If you put console.group at the top and then console.groupEnd at the bottom and you run this, you're going to get this nice nested structure. And that can be super helpful, especially if you're just logging a ton of stuff out. Now, this is still pretty visually noisy, so we can actually do better. We can say console.group collapsed and then rerun this. And then it's going to start all of these things already closed, so you can step in. And you don't actually even need to pass in an argument here, although you should. But it's just going in order. And you can do nested stuff too. So you can say console.group collapsed internally. This is another nested log group, and you can say console.log I, because we're in a for loop here, right? Console.groupEnd, and so when you step into any one of these, you can see this nice nested structure. So this can be a really clean way to just organize related stuff, and especially if it's not something that you always need to get into, but you'd like to have it there, just start it with a collapsed group, and then if you ever need to get into it for debugging, it's available, but it's not taking up a ton of like real estate in your console. One of the helpful utility functions on the console class is one that I would strongly advise you not to use because I think that it promotes sort of a false sense of security and obscures what's really going on in your code, but it's definitely still still worth it to be familiar with it. So let's imagine a hypothetical situation. We have some variable called foo, and it's undefined, right? We haven't initialized it yet. Somewhere much later in our application, because we're writing circa 2010 jQuery spaghetti and everything's everywhere, and you just, by the time you need foo, you're not quite sure if foo is initialized or not, right? So here, much later, we're going to say if not foo, console.error, foo wasn't set, right? When I run this, you can see, okay, foo wasn't set. If I set foo to a string value, then obviously this console.error never fires. So there is a console method designed to mimic this exact functionality, and it's called console.assert. And it works by taking an argument and an error message. And the logic says, if this argument is false or falsy, because it's JavaScript, so undefined counts, log this message as an error. So when I run that, we see assertion failed, foo wasn't set. So on the surface, that seems kind of healthy, right? Seems helpful. I can, just like I did before, I can assign a value to foo, and we will see that assert doesn't do anything, right? It turns into a no-op. And you might think, cool, I'm not going to like check to see if foo is set or not. I'm just going to do console.assert. That'll protect me. And then we can say console.log foo dot to uppercase, and when we run this, awesome, look, it took my string, it converted it to uppercase, assert never got in my way. But if this is undefined, your assertion fails, sure, but it doesn't do anything to actually handle that error. It doesn't do anything to increase the stability of your application. Using an assert here is just a shortcut to getting an error message printed to your console. It is not doing anything else. You can still get this calling a function on undefined, right? This is kind of a problematic method to me because it makes you feel like you're handling your error and you're not. So be aware of it. If there are cases where you're going to use it, cool. Just make sure you use it responsibly and you make sure that you understand what it's not doing. Have you ever needed to count how many times something happened when you're debugging something? like, let's say, for instance, we go for var I equals 0, I is less than 100, I plus plus, and var num equals math dot random times 100. And let's say if num is greater than 50, console.log number was greater than 50. Else console.log number was not, or let's just say it was less than 50, right? So if you log the same thing more than once, Chrome is going to give you a count of how many times that particular message was repeated. But like, this sucks, right? What we want to do now is like, crap, okay, so we got to keep a counter. We're going to say var num greater than 50 equals 0, var num less than 50 equals 0. So we've introduced this additional mutable state. And then we can say here greater than 50. And we can say plus plus num greater than 50. Here we can say less than 50. Right, now when we run this, we've got this running tally. So we can see 54 times it was greater than 50, 46 it was whatever. This is all wrong. I'm doing this just to show you that there is a better way. And we don't have to introduce these counters. We just use one of the many methods that they added to the console to make our lives easier. We can say count, console.count greater than 50. And here we can say console.count less than 50. And we run this, and that takes care of that for us automatically. Something we do a lot when we're profiling our applications, trying to make sure that we've optimized, we know how long everything takes to run, we want to figure out, just the durations of the various things we're doing. It can be helpful to time how long something took. So let's say we're going to create an array, and we're going to add 10 million objects to that array. Say array.push this new object, right? And I want to know how long this is going to take to do. Well, this is a great place to use one of the additional utility methods on the console. Rather than manually storing the start time and the end time and then doing our own duration computation, we can say console.time create objects, and then down here console.timeEnd create objects. As long as we're using the same key, it doesn't matter what the key is. So by saying console.time, we've created a timer with this key, and until we call console.timeEnd with the same key, it's just going to keep counting. Then when we call console.timeEnd, it's going to spit out a report for us. So you see what that looks like here. It's running, and you can see that's the label, and it took about 3 seconds in order to create these 10 million items and push them into our array. So my favorite one of the console utility logging methods is the one that I actually didn't know about until I started doing research to prepare for this course, and that is console.table. It works like this. Let's create a bunch of mock data first. So we're going to say function character that gets a name and a power. And then let's create a couple characters. Let's say var Buffy equals new character. Her name is Buffy. Her power is that she's the Slayer. Var Willow is a new character. Her name is Willow. Her power is that she's a witch. And var Spike is a new character. His name is Spike. And he's a vampire. If we wanted to create a list of these characters, we could say var cars equals Buffy, Willow, Spike. Now what if we wanted to log this out? Well, we know that console.log takes any type of argument we want to throw at it. So we can do that. and we can see that we've got an array of 3 characters. And we can open that up, and we can open that up, and we can see, you know, there's that character, there's that character, there's that character. That's great. But it's kind of a pain in the butt to have to step through and drill that down that deeply into what really is a pretty simple data set, right? So instead of using console.log, we can use console.table. And that's going to give us this beautifully rendered view that shows us every item in our array with its index. Because it's an array, we've got 0, 1, and 2. And then with all the properties of the objects in the array. We can take this a bit further, though. Well, not with arrays we can't. But if we wanted to change characters so that instead of being just an array, we wanted to make it an object, let's do var chars by name. We can say Buffy is Buffy, Willow is Willow, and Spike is Spike. So we can log out chars by name using console.table. And you can see when you've got an object with well-defined fields here that the index, instead of being 0, 1, 2 like it is in an array, instead becomes the name for that item in that array. And when you're logging out using console.table an object, you can specify a second argument here, which is the list of columns you want to show. So if I say only power, then I get the index, because you always get the index, and I get the power, and it removed the name. If I wanted to add name here, then we go back to our original view. And if I wanted to pass in an empty array, that's going to take out all of the fields except for the index.